All right, what we're going to do at this point is we're going to discuss another thing here in reasoning mathematically, where we talk about the idea of argument. Now, your text doesn't really address this directly. It talks about using the rules of logic, which we certainly will do. But it talks about rules of logic like modus ponens or modus tollens or the law of syllogism, and gives some fancy names, actually Latin names, to it. And frankly, you can look those up in the book, but they're not nearly as useful calling them by name in this case as they are learning how to just use a general rule of argument to begin with. Okay? So one thing about the process of argument is this, okay? You need to understand what an argument is, how it's put together, and then you need to understand how to check your conclusions. So the first thing is, an argument essentially is a set of premises, and premises are statements that we have determined to be true. And from those premises, you will arrive at a conclusion which should also be true. If you have true premises, okay, which lead to a true conclusion, then you have a valid argument. Now, this is a very, very restrictive form of reasoning here. What this means is that none of our premises can be false. They're not allowed to be false. The fact is that if you have a false premise, you can arrive at any conclusion and think it will become true. Okay. And by the way, you could have true premises and a true conclusion, but if the conclusion is not derived from the premises, then it's an invalid argument. So, for example, an example of an invalid argument would be saying, jobs are hard to come by, but I have a job, okay? Therefore, I have money in my bank account. Well, does the conclusion follow? Does having money in the bank account follow from having a job or from the idea that jobs are hard to come by? And the answer is no. Okay. And sometimes we have difficulty making sure that everything is connected. But here we're going to try something which is a little bit better. We want true premises which lead to a true conclusion and only lead us to a true conclusion. And that's what we're going to consider to be a valid argument. So let's start off with an example. This is a valid argument, okay? So all kids are rowdy, and Jesse is a kid. Now, just a moment here. You said, well, not all kids are rowdy. You can't say that. Well, okay. Here's the idea in logic and in presenting an argument. Okay. These are premises, statements that we assume to be true. Okay. Now, they're what we assume to be true. And under those conditions, if these statements are true, would this follow from that and this be true? Part of our difficulties in dealing with things logically, perhaps as a nation, is the fact that sometimes we can't decide what statements are true or not. So there are some very, very large national debates, okay, with over certain ideas. Okay, gun control, for example, a big national debate over gun control, big national debate over abortion, big debates over a lot of other things that we can. And part of the problem is that these people who are on perfectly different sides could, if they were thinking about it rationally and not emotionally, okay, line up statements that they assume to be true and come to a conclusion. Now, would they necessarily use the same statements? And the answer is no. Would they, if they were comparing statements, would they necessarily agree with another person's statement that the other person had assigned a truth value to? And the answer is definitely not. Okay. And so when you take a look at some of these things, okay, you have to evaluate logic as if this statement is true, if these statements are true, does this conclusion have to follow from that? And if so, it's a valid argument. Now, you might be able to destroy its worthlessness by showing that the statements aren't true. But nevertheless, we sometimes throw out the accusation that somebody isn't thinking rationally when they are. It's just that they disagree with you about what actually are the facts. Okay. So here, let's suppose all kids are rowdy and Jesse is a kid. Well, what is the proper conclusion for that? Well, we can say that then Jesse is rowdy. Well, let's see if we can find a way to demonstrate that. Unfortunately, there is a nice little way for us to demonstrate that called Euler Diagrams. And here, if I talk about two classes here, here's kids, and here's rowdy, then I can make the statement that all kids are rowdy. Now understand, this what is going, all kids are rowdy. Or if you happen to be a kid, then you are rowdy. Okay. Now let's see why this one wouldn't work. Okay. So here's rowdy, and here's kids. Okay. Does this work for all kids are rowdy? And the answer is no, because here you have some kids that aren't rowdy, right? Or the possibility. Okay. So this one really doesn't work. By the way, this says that all rowdy people are kids. That's not the same as saying all kids are rowdy people. So we're just going to say that one doesn't work, and we're going to use this. Well, what do I know about Jesse? I can place Jesse into a category, and here I've placed Jesse into a category of kids. Well, what does that say about Jesse? Jesse is rowdy. So what I have done is I have demonstrated that this argument is valid. Now, if you remember, we had another argument up a little bit ago. And here was the argument. If you eat your broccoli, then you can go out to play. Okay? And you did not eat the broccoli, and therefore the conclusion is you can't go out to play. Okay? And so what we're going to do is we're going to try to draw this and see what happens. I told you it wasn't necessarily a good argument, all right? So here, if you eat your broccoli, then you can go out to play. Well, now notice here's what it says. If you eat your broccoli, then you can go out to play. Notice that this is not this is not it, okay? Play and eat. Here, in this case, you can eat your broccoli and not be allowed to go out to play, just by being in the wrong spot. Okay? The only way that you would be guaranteed, if you eat your broccoli, then you can go out to play, is this little situation here, where if you eat your broccoli, then you are clear and free. Okay? Now notice, okay, that this provides us, though, with some other things. If you didn't eat your broccoli, then you're either here or here. Now, does this mean you can't go out to play? No. It doesn't mean that you can't go out to play. It's possible that you could be allowed to go out to play and no promise would have been broken. And it's possible you might not be allowed to go out to play. Not eating your broccoli does not necessarily mean automatically you can't go out to play. What does it mean? It means you're not guaranteed that you can go out to play. This statement right here tells you what will happen if you eat your broccoli. It doesn't tell you what will happen if you don't eat your broccoli. Now, what we're doing here is we're examining the process of argument. Okay, here are our premises. This is the conclusion. This one happens to be invalid. It is invalid because I cannot support this conclusion by the premises. So, suppose the conclusion is true. I can't go out to play. I'm not allowed to go out to play because I didn't eat my broccoli. Well, I still can't necessarily support that by the conclusion. That is not the only conclusion that could be arrived at. Now, using rules of logic can be done formally or informally. This is still deductive reasoning. Notice I'm still using rules here, my premises, which are assumed to be true. Here's the general rule. Here's something I'm going to compare against the rule. This is my conclusion. Is my conclusion valid or invalid? And I can use rules of logic to handle things for which the rules of logic are good for. We do live in a society where there are rules, okay? If you go faster than the speed limit, then the cop can give you a ticket, okay, for speeding. Of course, the cop can give you tickets for other things as well. But general ideas. We need to think about how to allow our students to reason mathematically, and part of it is going to be by saying, well, what do you know about the rules, and how does this fit within the rules? That's part of it. Deductive reasoning is a part of mathematical thinking.